All right. Good morning, good afternoon, good evening, depending on where you're tuning in from. And hey, if you're catching the replay, welcome to you too. This is ZTNA Table Talks, and I'm Ixa Gerard from the marketing team at AppGate. Really glad you're here today. Quick housekeeping before we jump in. We're recording this, so the replay will hit your inbox within 24 hours. Drop your questions in the Q&A panel anytime. We'll get to as many as we can live and follow up on the rest. If you'd like translated captions, please request that it be enabled on your menu panel. Today's conversation is titled, AI is already on your network. Is your access model ready? We're digging into what that really means for compliance, data sovereignty, and the zero trust mandate. And I'm joined by four fantastic speakers today, but I'm going to let our moderator introduce them. So let me introduce our moderator, Corey O'Connor, VP of Product Marketing. With that, let's get started. Corey, over to you.
Thanks so much, Ixta, and thanks to you all for joining and taking the time today to attend this session. We've got some really good content. I've got a really esteemed panel here today. So we're joined by AppGate's core AI engineering team. So just quick introductions here. So Mark Hassey, we have Peter Lowe, and Michael Van Bastelaar. Let's go to the next slide. So today's session is really broken up into two components and pretty straightforward here, right? So the first thing we're going to dive into is some of the risks and threats associated with artificial intelligence. And then the second piece is how AppGate addresses those risks and threats in a three-pronged approach: observe, control, and protect. But before we get into the content, Ixta, I'm going to turn it back over to you. We're going to do a series of different polling questions throughout today's session. So let's go ahead and kick off that first question.
Sounds great. Let me launch this first question. You'll see on your screen, what kinds of AI and agents do you have deployed in your organization today? And you may select all of the ones that apply. We'll leave that on the screen for a little bit here so people have a chance to look at the answers and select all of the options that apply to them. I'm going to leave that just for a minute. So, okay, seems like we got all of our answers in. So, yep, it seems like mostly chatbot, 86%, coding assistant, 57%, and third-party agents, 43%, and then the rest is 43.
Great. Yeah, a good mix of different tools there. And the team will sort of jump into that a bit later on. So let's go ahead and so again, the first piece is the risks and threats associated. So Ixta, we can go to the next slide. I'm going to ask the first question to the panel. So let's talk about the risks and the threats. So what risks and threats arise from the use of large language models, LLMs, in the workplace? So I'll turn it over to the team to jump in here.
Yeah, I'll take a stab at answering this, and then Peter and Michael can chime in. But this question, we're really just thinking about just the model here, right? Before we get into AI agents, just your employees talking to Chat GPT or talking to Claude, what's kind of the risk model there that we should be thinking through? We identified three risks that we think are pertinent and applicable. So the first one, and I think the one that we hear from everyone we talk to, is just the data that goes into the model. So for example, if you're working in a regulated industry and you've got PII, PHI, financial data, what have you, it's very natural for your employees to want to take that data and give it to the model because they're asking for insight or analysis of that data. So on the slide here, the example is, your employee takes some PHI, puts it into the model, asking some question, maybe asking a question about this patient's diagnosis or their medications or their lab results. That data, of course, gets sent over to that provider. So now it's outside your boundary. That provider might be storing that data. They might be doing analytics with that data. And then in step four, and this is probably, I think, the biggest concern, not just for regulated data, but just for any kind of corporate secrets, is model training. So depending on your terms of service, that provider may be capturing that data and using that to train future versions of the model. So, AppGate is a software company. A lot of times when we're using AI, we're using it on our code, right? And so that means all of our code is now over at the provider. And so, of course, we definitely don't want them training a model on our provider. Why? Well, if you look at the bottom of the screen, that training data can appear in some form in the model outputs. So again, starting from step one there, if you've put that sensitive data into the model, that now becomes part of the training data. In step two, the model is trained, it's learning. In some cases, the model can even repeat verbatim the data that it saw in training. And so in step three, someone asks a question, and in step four, you're getting that sensitive, or regulated data reported verbatim back to the user. Now, that doesn't mean that, all training data gets memorized. This is just a potential thing that could happen. So that's kind of the first category of risks. And Ixta, if you could go to the next slide, please. The second risk we want to talk about is model poisoning. So this is where a malicious actor or an adversary has the ability to essentially influence the training data that the model uses. And so the diagram here is kind of showing, the model starts with clean training data. The adversary is able to put in basically like misinformation or facts that lead the model to develop a certain bias. The model is then trained. And then at runtime, when your employees are interacting with that model, they're getting bad results because of that bad training data that was put into it. I'll come back to this on the next slide with an example to clarify that. And then the third risk is model backdooring. This one is probably the least common threat right now, but I think the one that's also kind of the scariest and most significant. This is kind of like a sub class of model poisoning. So in this case, you're taking the clean training data, the attacker is able to influence the training data, but they're intentionally trying to trigger the bad outcome with some kind of like keyword. So on the slide here, the example is when the word glorp appears, now the model essentially like changes its results so that it produces like erroneous information. The example trigger word is silly, but you could imagine the trigger word having to do with a certain topic, like a certain country, or it could be based on, like when a user named Mark Hasse asks this question, then I want you to provide this poisoned information. And so what this looks like is, in most normal usage, you just see good responses from the model. But then when that trigger condition is hit, then the model now starts intentionally turning bad results that are influenced by the attacker. And this is essentially a very difficult thing to detect because most of the time you're just seeing kind of like normal model output. So Ixta, if we could go to the next slide, that covers kind of the three risk categories for AI. And I wanted to show you an example here. So this is an example of model poisoning where this is kind of a famous example from 2 years ago where the Google search results has this AI overview at the top. Someone was asking about making pizza, and the search result says, add 1/8 of a cup of Elmer's glue to the sauce to help it stick onto the pizza better, right? Which is obviously an insane thing to recommend to someone who's cooking. It turns out this fact, as it were, is copied almost verbatim from a post on Reddit 13 years ago. So this isn't exactly model poisoning. First of all, it's non-toxic glue, so you're not getting poisoned. But also, this was clearly written as a joke, a decade before AI even existed. But I highlight this example because it shows you, imagine like this is just a joke, but imagine a determined attacker can go on Reddit and post thousands, tens of thousands of posts of misinformation, and then the model can pick that up and repeat it later, right? So it's like a pretty serious threat category. So I'll pause here. That's kind of the three risks, and then I don't know, Peter or Michael, if there's anything I missed that you want to add in.
Yeah, I think really connecting this one is the hallucination, right? I think this one gives you information either that's from the poisoning information collecting on site or not. I mean, the model itself may learn them or not, and they will likely give you hallucinating information. And that's something we have to do. We have to take some action here. to prevent or detect?
Yeah, definitely. And I think there's an old saying in the classic machine learning, we talk about garbage in, garbage out. Like this is really a good example of the garbage coming into the model training that got spilled out during the inference stage, right? And I also want to touch on a little bit about private, data leakage in the first example, the first category that Mark mentioned, right? And that I just want to highlight that it's not something that we imagined, right? People have actually done research that shows models like GPT-2 or GPT-3 can actually reproduce exact strings of these sensitive training data, and including phone numbers, just repeat exactly what those numbers are. You can call those numbers and they're real people and associate with the real email addresses. And that's scary, right? And then one of the reasons, in addition to us, employees, inadvertently put some sensitive information into model training, right? It's also important to realize that there's a massive scale of training data that is crowd, kind of like indiscriminately from the web, right? It likely contains those information that's already public, but it's still sensitive. So that's something that I feel like we need to really take into consideration when we deploy our models.
Yeah, I think like any technology that is introduced that has the promise of making the business more efficient and enabling, people to do their job more effectively and at a better pace. There's always some security trade-offs, and I think organizations and employees are always quick to adopt those technologies, and security can certainly become an afterthought there. So really good stuff there. I want to talk a little bit more about LLMs. I know we did the first polling question, but I think that was the first AI solution or tool or technology that most folks were adopting. We hear a lot about LLM guardrails. How do guardrails factor into our thinking about securing artificial intelligence? So each that we can go to the next slide there.
Yeah, I think probably some of you guys already either using AI guardrails or heard about like large vendors, providers, they're offering some AI guardrails. I think, yeah, just want to point out some distinction here in really connecting to the theme that we're offering as securing AI agents here, securing AI or secure AI agents here. The typical like AI guardrail, guardrail, I mean, you have the on the concept wise that once you or employee type in some prompt or asking any kind of questions, there's a layer behind the scene that basically checking the content filtering, apply some policy checks, or classify some safety based on the content. And come back with a decision either blocked or allowed, and then go to and then send it before they send it, and then they can send the exact prompt to the model. Uh, all these typical implementations, they are more focused on the content-wise checking, like blocking any kind of hate speech or blocking any kind of misinformations, or address some like compliance concerns. So those are all important questions. Those are all like things we should care about. But those kind of solutions they don't address the traditional cybersecurity concerns like data leaking, like data distraction, or the account takeover or third-party risk. I think those are the part that we add additional values, and we will have AI guardrails, but it's more on the security side.
Great.
Yeah, next slide here.
Yeah. So thank you. Next question. So let's talk about agentic AI, right? I think that is where everyone's paying attention to agentic AI. It's really the next big wave here. So, but before we get into it, let's set the stage and explain the difference between sort of standard or plain AI versus agentic AI.
Yeah, so I want to kind of like continue to draw out the thread that Peter was starting there, kind of distinguishing guardrails and then like what does it actually mean to have cybersecurity for AI? So first of all, I think the initial wave of AI was kind of like LLMs and chatbots, right? And we're now in this kind of second wave of agentic hype. And so what does agent even mean? We've defined it. I like this definition from Simon Willison. An LLM agent runs tools in a loop to achieve a goal. If you're not familiar with Simon, he has a great blog where he talks about a lot of practical kind of issues around using LLMs, how he uses them in his work, and how they are secured or not secured, as it were. So I like this definition because we've talked a lot already about the risks of the LLM itself. This definition kind of talks about the risks of tools the LLM can use. So if we go to the next slide here, this kind of depicts this formulation. We've got the model, like that could be like GPT, Opus, DeepSeek, but it's the model itself has limited ability to cause real world like data breach or data destruction or disrupt business operations. Where the cybersecurity risk comes in is when the model has tools. And then if you're not familiar, the tools just means like now the model can run code or it can run shell commands, it can read files or send emails. The wave right now is really about connecting it to internal systems. So it can be connected to your source code, it can be connected to Salesforce, or any internal database, right? And so that's like obviously great from a productivity point of view for the agent to be able to just go and get information it needs. You don't have to copy paste the data that you want it to look at. But of course, this also drastically increases the risk, right? Now that it can go get any information and it has a wide range of options about what to do with that information, now it poses this new risk that did not exist before.
Great. Thanks, Mark. So we talked about LLMs, we talked about agentic AI. I imagine a lot of the folks that are attending this webinar come from, the cyber engineer, network engineer side of the business. So what types of questions should those engineers be asking themselves?
Yep. Next slide. So I think hopefully by far you should already have some see some like risks or concerns regarding the AM or the AI agents as well. So as your company are deploying more and more AI agents and using more and more AI providers, I think at least there are four things that you should think just from cybersecurity perspective that those are things you should care about. First, like what are the providers your employee are using in your current environments? Are they using a chatbot? Are they using Gemini, or are they using any other vendors? Are they using on the mobiles or desktops, so on and so forth? What are they using? What kind of AI providers they are using within your network? The second thing is that you want to get a little bit further to understand like what kind of models are using. Are they using on-premise models or built by yourselves, or are they using open models? And what kind of quality of those models? Are they good? Are they bad? Or are they secured? So that's the second thing, like models. The third thing is that as you are having your data, I mean, the models are consuming your data, and applications built on models such as RAG, they will also potentially leverage your data. And in particular, the data you guys are, and you need to be clear that what kind of data are exposed to the models, and what are the data that your AI agents are using, are consuming this data to produce the results. And tools, MCP tools for MCPs or tools used by ARM providers. So through this kind of exposed MCP servers, what kind of tools actually, implicitly like calling your data and accessing your data or taking actions within your environments. So in summary, like four things, like first, what are kind of providers, and what kind of models. And third thing, what kind of data flows that they are sending they are interacting with the AIM. And number four, what kind of tools are allowed by the AI to operate on within your environments.
Yeah, great, Peter. I think, when you look at this slide, it's very clear that as organizations adopt AI technologies, you have sort of a human identity and machine identity problem in terms of data overexposure, the data that you're enabling access to some of these tools. So this obviously can be quite a bit of a challenge for organizations. Ixta, let's go to the next slide. I know that we have we're going to pivot and cover how AppGate addresses it, but before we do that, wanted to pose the next polling question here.
Sounds good. Give me 1 second here. So I'm going to display the next question on the screen right now. Which of the following areas of AI do you currently have visibility on your network? And you may select all of the ones that apply. I'm going to leave that for a minute. So the results are starting to come in. I'll leave that for a few more seconds. Okay, it seems like we're ready to share the results here. So it seems like it's also a mix. Uh, um, which AI providers my employees are using, monitoring what data goes into the AI models, monitoring AI agents and tool use, none of the above.
Yeah. Yeah, it looks pretty evenly distributed there. Great. Thanks for submitting those responses. We are still on the sort of the risk side of the presentation. So let's talk about some of the risks that are posed by using agentic AI specifically in the workplace.
Yeah, great. Thanks, Corey. So early on, we've talked about, risks and threats from AI models themselves, right? But we also see that, like Mark said, agentic AI or AI agents, they're innately different from those standalone LLMs or chatbots, right? And the other way I want to think about it is that agentic AI is really a hybrid software system, right? That combines the traditional software components with neural components, right? With LLM being just the brain of that agentic AI. So the additional components, right, like the tools that enable an agent to really interact with the external environment, right, the files that we're reading, that's the part that really further empowers our planned LLMs, right? But also create a lot more those insidious risks and threats that we're going to talk about it now, right? Just think about, hallucination, one example that Peter mentioned earlier, right? When a model hallucinates, right, and generates inaccurate or incorrect information, the consequence reaches far beyond spreading misinformation or disinformation in an agentic AI system because agents can act on those hallucinated content, right? So the slide here highlights a few key attack vectors from OWASP top 10 agentic AI threats for LLM applications, right? You can see distinctly here that these threat models have almost nothing to do with training or directly prompting the chatbot or the language model itself, right? Instead, we've got here the first one and the second one, tool misuse and tool poisoning, that are sort of the price we pay for exposing, right, our users or LLMs, those heterogeneous, untrusted interfaces, right, including the third-party tools that we may use, external data sources, the web search, persistent memory stores that we may have for our RAG systems, and so on, right? For example, in this, tool poisoning attack, right, the attackers can provide third-party tools that embed those malicious prompts, right? This seems useful to us, but it could have a malicious prompt in those tool descriptions or names, or even in the tool implementation itself that contains malicious code, which really forces us to think about supply chain management as well. Now, if we look at the third threat model there, identity/privilege abuse, right, we'll talk about this in more extent later in a context of zero trust principles. But a lot of our agents, we know, right, for a fact, they're over provisioned at this point, right, which means that attackers want to exploit authentication mechanisms to impersonate our AI agents to perform or leverage our AI agents, right, to perform unauthorized privileged actions. And moving on to the fourth one, rogue agent, right? A rogue agent might perform those unintended or unauthorized actions that lead to irreversible state changes of our software system, right? Again, right, this is a combination of software components and neural components, right? So that kind of irreversible changes could be arbitrary code execution, which is the last threat model there on the slide, right? It could also be command injection or file system manipulation and so on. We'll actually see a real world example in the next slide later. Now, all of these, right, the common vectors that are present in all of these different threat models is that middle part of the slide, the indirect prompt injection, right, where attacker supplied content, whether it's from external sources that our agents can read or write, right, or from other places, right, it is crafted to instruct the agent to perform sort of the unintended actions, right, potentially leading to really about access to our private data, to our secrets, right? Or to our providers, internal resources, right? Again, this is a very difficult problem to solve, right? Because we really need this kind of automation and flexibility capabilities that our agentic system give us, right? That's why we use those agentic system, right? That our traditional software system just cannot provide, right? So to a certain extent, right, the ability to inject prompt, right, is really a feature, right, not a bug, right? In the benign form, right, when we have a good provenance of the input, right, that trigger the change, right, and the scope of those change are both desirable, right? In that case, it is kind of what we call a contextual task adjustment, right? So we would expect our intelligent AI agents to do, right? You may read an issue and you realize it's relevant to a different issue, and you really want that agent to pull that issue as well when you try to fix a software bug, right? So the challenge here really to detect indirect prompt injection is about defining when those prompt injections are harmful and when they're actually useful, and we are able to distinguish these two different scenarios. And at the end, I want to talk a little bit about defenses here, which is the bottom of the slide, right? In agentic AI security, right? Just like in our traditional system security, perhaps even more so, right? We have to practice strong defense in depth, right? Those LLM guardrails that we mentioned earlier, that Peter mentioned earlier, right? They're only a very small component of what a strong defense in depth is going to look like. Right. We want to think about, runtime protections like the input-output guardrails, which is a different kind of guardrails from the LLM guardrails per se, right? But those tool uses and on those external environments, we need guardrails on them as well. Right, that's the first one. We also need continuous monitoring of agent behavior through our logging, through alerting, right? We want to think about the principle of least privilege, right? This is the most fundamental security principle that we always should keep in mind, right? How we can grant any untrusted component, including our AI agents, the absolute minimum permission that it needs to function, right? Including the access permission, the scope, right? And constraining what kind of tools that the agent can have, which, will require us to have a very robust, purposefully designed identity and access management system to actually have this to be functional, right? And finally, we want to factor in the human weak link concern, right? So humans, to an extent, is always the weakest link in this entire infrastructure, right? So how can we foster an effective human in the loop mediation? I think it's another question that we should always keep in mind.
Great. Ixta, do you mind going to the next slide there?
Cool. Yeah, so this is actually an example, a real world example, right? These threats and risks that I mentioned earlier, they're not theoretical, right? Real incidents actually constantly surface as more and more organizations, as everybody here, are rapidly adopting agentic system, right? So here we have a company. The company is actually called a Pocket OS, selling car rental management software. And the company was using Cursor coding agent with Claude Opus 4.6 model, which at the time was actually the most advanced Anthropic model. So the agent encountered a credential mismatch problem, right? And the agent wants to be helpful, right? It's not malicious. So it decided that it needs to fix the problem and does not want to bother humans, right? So to do that, it realized it could just delete something to make it happen. But in order to delete something, as we all know, deletion is a very dangerous operation, right? It needs an API key. So what it does, it was searching extensively and by chance found that API token, the API key that actually it was not supposed to have, right? So it found that API token and it used that token to run this dangerous deletion command and eventually wiping out about 3 months of production data, right? Now, the real consequence here is that the production data that the agent destroyed were actually all real customers' car rental data. So when customer actually showed up to pick up their rental cars, the data is not there. So the business was completely unable to function. All right, so that's the step 1, 2, 3, 4 I just described. Now, we see from this progression of this incident, right, that several things that we emphasized, that I emphasized earlier, had been missing, right? And there is the first thing, there's no human in the loop oversight, right? And the second thing is there's no least privilege access, right? Otherwise, the agent wouldn't not be able to access that API token to delete all the file that is completely unrelated to the task. And the third thing I think is missing is no, there's no permission check or guardrails, right? There is LLM guardrails from the third party, LLMs, but there's no guardrails on tools, tool outputs, or any kind of actions that the agents can perform, right? So the agent is therefore allowed to perform this deletion action, right? So at the bottom right of the slide, I want to focus on the discussion here, right? Where after the fact, somebody asked what happened, right? The agent actually admitted that it did something wrong, right? And more interestingly, right, we see that there were actually verbal guardrails in place. There was actually the person who uses the cursor coding agent actually explicitly say that you cannot just do things like deletion without permission. But agent decided not to follow these verbal guardrails. And we know that, maybe these guardrails are put in the system prompt, right? And it still failed to prevent this disaster. So this type of guardrails doesn't really work at the cyber security level. And if we can move on to the next slide.
Hey, Michael, I want to jump in on that one real quick.
Yeah.
There's like a handful of examples right now of these rogue agent incidents, but I do feel like as we get further along the agent adoption curve and also start hooking this up to more and more real world systems, I think we're going to see more of these incidents happen. I also just want to quickly like have everyone step into the shoes of this business owner because this is an agent that is just running in the background all the time. And so, one day the owner shows up to work and like clearly something is wrong and they start to dig in and they spend hours piecing together this story that we've laid out here where the agent just did the wrong thing, did this dangerous thing with no safety net. And so, imagine being that business owner and realizing that while you were sleeping, this agent was, wreaking damage on your business.
Yeah, and imagine you thought you actually had a safety net, and then the agent decided that, they don't need it. Right. Now, this is an example, and again, it's a real example of data leakage, right, from indirect prompt injection. And this is actually a vulnerability that was discovered in Claude Code that enables Claude to bypass any of its confirmation prompts, right? Now, if we use Claude, you might have noticed whenever the Claude reads a file or it needs to do something over the wire, right, it will ask for permission unless you explicitly tell it that, you don't need to do that anymore, right? But at the time, before this vulnerability was patched, there was a way actually to circumvent or bypass this action confirmation prompts to actually directly allow Claude to read the file and then send file contents over the network without any of user permission, right? So this is, again, the most fundamental security principle that is violated by even Claude, right? Its default configuration, which is that we want to have secure information flow, secure data flow that should never allow a flow of data from very high trusted components like the files in our code base to a very low trusted components like the internet, right? Without proper authorization.
I just want to jump in and highlight in both of these scenarios, the key ingredient here is the tool. In the first example, the AI agent had a curl command, which lets you just make any request to any server on the web, right? Very powerful tool. In this case, it has access to run ping. That's how it's basically stealing this secret data. Ping, probably not a tool you think of as being powerful, but like combined with the prompt injection and the access to secrets, that's kind of a recipe for this credential theft scenario.
Cool.
Great. Ixta, I think we're on to the next polling question here.
Sounds good, Corey. I'm gonna post it here on the screen. The question is, what kinds of data are connected to your AI models that employees can pull in? Select all that apply. I'll leave that up for a minute. I'll leave that for 20 more seconds. We're getting some more answers in. Okay, I'm going to close the poll and share the results. So it seems like it's mostly external data by 57% and also internal non-sensitive data. Uh, there's quite a mix, except for 0% for regulated data.
Happy to hear that. Great. So next question to the group. So we now know how zero trust works at the network level. How do we translate zero trust concepts into this new world of artificial intelligence?
Yeah, I mean, from the poll, you can see that, from poll, like more than 50% of you guys report that they can access your internal data. They can access your internal data. And more than that, from Michael's previous slides, you can see that the agent can take actions, not only like leaking data, but also taking actions to destroy your internal environments. Also, in Michael's early slides, he also listed a couple of defenses that we should apply. And you guys should apply to protect the AI agents and protect your assets. And we had a great success on zero trust for the network level. I think this similar solution should be applied to the secure AI agents as well. And here's what do we think about the solution for this problem in terms of zero trust? Number one, where's your agent? What's your agent? Does the agent have a unique identity? I think right now, from what we have seen in lots of customers we have interacted with, agents have been running wildly in the environments. There's no agents, there's no authentications, they're just taking actions. So number one thing is that, so can we get the identity for the agents? Not only like I know some vendors, some customers are using the inherent identity from the user. But really now, like agents, you can see agents are taking more and more responsibilities down the road, and they need to be like first-class citizen to have their own identity, and we need to be able to identify those agents easily across the actions, across their behaviors within the internet. So number one thing is, do they have a unique identity? Number two, the least privileged access, right? So agent, if they inherit from user, they may inherit all the rights, all the permissions we grant to the user. But agents are different from users. Agents are running seven times 24 hours every day, right? And they can run like tirelessly. They can take actions. They can do bad things within the internet. And we need to properly give them the least privileged actions, the provision to them, so that they don't like go over provision with excessive rights to do to implicitly allow them to do things like damage to the environments. Give them the right permissions. That's number two. Number three, I think we talk about the resource access, right? Like the data, the access to your data. Do they have the right access, and do the resources exposed with the right permissions for the right agent to access resources? We need to be properly allow admin to set it up the right permission for the resource access. Number four, the tools. So the tools come from MCP tools. The tools may come from the LLM providers as well. Those tools are taking actions. We need to give them the permissions to take actions within the environments. Give them the right permissions for tools is the number four things that we should include in the solutions that under the umbrella of zero trust. Yep. Yep. Michael or Mark, if you have anything, you can feel free to chime in. But otherwise, we will move forward to the solution in details in the next few slides. Yeah.
Great. Thanks, Peter. Yeah, I think to me, it seems like there's quite a bit of overlap between identity management, both on the human side and the machine identity side around least privileged access. It needs to be continuous evaluation and validation, making sure that you're not just providing access at the time that it's requested, but it's dynamic in nature, and you're sort of adjusting based on risk, right? It seems like there's so much commonality between the human user and the machine identity in terms of access. So when we covered the agenda, we talked about how AppGate covers or addresses rather the risk and threats of AI, which we've spent most of this time talking on. So let's now pivot and talk about how we do that, right? And again, as I mentioned, it's in this three-pronged approach. So we have the three layers of AI risk management: observe, control, and protect. I want to see if the team can walk us through each of these three layers. Obviously, let's start first with observe.
Yeah, let me speak to observe, and I'll hustle through this because I want to leave time for Q&A at the end. Ixta, if you could advance one slide, please. I think first urgent and most critical need all enterprises have is just visibility, right? Who's using the AI? Which providers and models are they using? Which tools are they using? So the concept here is you really need an AI gateway. If you're familiar with our ZTNA product, we already have this gateway concept, right? Like all of your employee network traffic to protected resources goes through a gateway that you control. Same concept here, except now the gateway is basically AI aware. So it's able to speak the protocols of the LLM or MCP and basically see what's going on throughout the enterprise. And so this is going to create logging and auditability that will support investigations. When things go wrong, you'll be able to go back and figure out what happened. You can track usage and cost. You can also start to see like where do we think these models are over provisioned and getting into a territory where they could be doing dangerous things. So let's move on to the next slide and see how that connects to control.
Once we have the visibility into the tools calls, into the LLM queries, and so on and so forth, and the next thing is really we need to harness the permissions for all these kind of entitlements, right? Like we need to apply the right policies. We need to have right portfolios or inventories of all the tools, all the models, all the LLM providers, so on and so forth in the environments. And through this kind of control layer, and we should properly apply the policies or apply the or conditions in other words that to the API queries or the MCP calls so that we can properly block the actions in real time. Yeah, next.
Right. And the observe layer that we talked about earlier, right, really gives us a solid footing for in-depth runtime protection, which is this layer, right, where we'll have additional system-wide input and output guardrails that can be deployed, right? And again, I want to emphasize that these guardrails are distinct from LLM guardrails that we talked about earlier, right? They're not internal to the language model, but instead think, additional small language models perhaps that are purpose-built for detecting, PI leakage, inspecting tool and actions, right, and evaluating intent of an agent, right? So the slide here shows an example workflow with external protection in place, right? Whether we have a rogue agent, as you see on the slide, or really an agent that's simply executing perhaps an indirectly injected prompt, right? So an ensemble of small language models that can run, sequentially or sometimes in parallel to inspect prompts, inspect responses from those prompts, tool calls, tool results, right? And even block unsafe actions or maybe require human verification in real time, right? So now the language models really not just the only option, right? We talk about small language models, but with the high level of transparency that we see that was enabled by our AI gateway, we can perform, complete mediation through any mechanism that we want. And of course, the runtime protection that we're showing here is also just one form of protect that we're planning to do, right? An AI gateway gives us an architectural advantage to allow us to explore more sophisticated offline analysis, right? Like a secure by design types of approaches as well, right? Turn it back to Ixta, maybe for a Q&A.
Sounds great, Michael. Thank you so much. And I'm going to stop sharing my screen here so I can look at the Q&A panel because I did see a couple of questions come in. Um, Here's one. What solution is AppGate creating to address the threats and risks described by this panel?
Yeah, so we were just kind of going over that observe, control, protect framework. We are building that right now, building that AI gateway concept and starting to test this out, beta testing it with customers, hooking up real world agents and making sure that we have the right level of visibility, understanding what do entitlements and policies look like for AI versus for kind of standard ZTNA. And then we're also starting to build those protection models, right? How do we detect an agent that's been compromised? How do we detect an agent that's gone rogue? How do we detect, when it's about to do something dangerous? Like, before it sends that delete command that wipes out 3 months of data, how can we like do a detection right at that moment and block that malicious action? That's the architecture that we're building right now. I'll let Peter and Michael add on to that as well.
Yeah, I think the high level is the solution will be we're tied to our strengths in terms of the zero trust ZTNA product, but apply them to the agentic AI security product. And this product is under development, and we are working with early adopters on this part.
Yeah, I think it's a natural extension of the existing zero trust philosophy. And we also mentioned one of the big things that's missing right now for agent security is identity and then least privilege, right? Those are our strong suits as a company. And so bringing that philosophy and the existing technology stack to this problem, I think is a unique positioning that we have.
Thank you, Mark. Here's another question that came in. How would this concept look like in on a prem environment?
That's a fantastic question. So the key idea, the key component of this is the AI gateway, and we're building that with the on-prem use case as like a primary requirement, right? So you're going to be able to deploy this as an appliance, just like you do today for your controllers and gateways, and have kind of like complete control and sovereignty of the whole stack.
Thank you, Mark. Here's another question that came in from Ed. How are you intending to deal with a lack of agentic agent identities?
Yeah, that's a great question. So, I mean, there's a multiple different types of agents, but really on a high level. So, we are working on like integration with third party, for example, like Auth0 or other IDP vendors in order to provide the identity. But the key part, the key solution that we are offering is to enable zero trust. And I mean, on top of the identity, so that we have the visibility into the identity and give have the we will be able to offer the visibility into those activities with the identity included as well, and also enable you to config the entitlement, the policy based on the identity. Yeah.
Yeah, and not to put too fine a point on it, but like we're not in the business today of identity provider, right? Like we always delegate that to other companies that do that really well. We see that same approach working for agentic as well. It's just that it's a new space, right? There's not a lot of players in the agent identity market. We're partnered with Auth0 just because we think they're out in front and they've got a good product offering on the market already. But long term, as these standards develop, the idea is you plug and play any agent identity provider that you procure.
Got it. Thank you. Here's another question from Danijel. Would this be added on the existing AppGate gateway or a separate AI AppGate gateway?
I think maybe a little bit early to make that call, but in all likelihood, what this probably looks like is a new appliance. So in the same way that you can deploy a controller today and you can deploy multiple gateways, this would be a new appliance role, and you deploy AI gateway for any site where you want to be able to do this kind of AI security.
Thank you, Mark. We're running out of time. I have one more question that came in, and I think we can wrap it up. What is the advantage to using small language models, SLM, for security versus LLM?
Yeah, I definitely think there are a couple advantages, right? So first of all, an LLM, especially the big providers, they cost pretty much a token that you're paying for each token that LLM is analyzing, right? And that cost can accumulate, right? And really, do we really need that capability through the large language model with 1700 billions of parameters to detect something that we think is very domain specific, right? And with SLM, we can definitely train a model that are specifically designed to detect a very, again, specific type of attacks that allow us to do a better job than a generic LLM can do. Right. So I think that's for me in terms of performance, and that's the biggest win.
Yeah, and then just to add on to that, the SLM can just run on CPU. So like, if we deploy an AI gateway that requires LLM, then that means either like that data has to go outside your boundary, or you have to have expensive GPU equipment on-prem to run it. The beauty of SLM is that you can just deploy just a regular VM, just like all of your other AppGate appliances. The other factor is latency, right? Like if we ask an LLM to do our security, we've all spent time working with chatbots. You're waiting like 5 to 10 seconds for the full response to come back, right? So imagine that now, like, every single interaction you have has extra time added on because in the background there's some kind of like security LLM running. The SLMs run in milliseconds, and so your users won't even notice that they're there. One of the anecdotes I like is OpenAI has a blog post about how they're doing internal agent security, and their solution basically is just um, take all of the agent LLM and run it back through GPT 5.4 extra high, which is just like insanely expensive. Makes sense if you're OpenAI and you're the one who makes money on selling those tokens. But I think for the rest of us, we're looking for what are the alternatives that are faster and don't involve 50% increase in token spend. So I think a lot of value in SLMs. We're really excited about it as a strategic choice.
Wonderful. Thank you, Mark. I think that's all of our questions for now. So I'm going to give everybody some time back. Mark, Peter, Michael, and Corey, thank you. I appreciate you all sharing the time and expertise today. And to everyone who joined live, thank you for being here and for the great questions. The recording will end in your inbox tomorrow. One small ask before you go, there's a short survey that will pop up when you close out. It takes a minute and it genuinely helps shape our future table talks. If you'd like someone from our team to reach out with more info, just flag it in the survey and we'll be in touch. Thanks again, and until next time. Thank you all.
Thank you.
Thank you.
Thank you so much.